Hi everyone. So as you can see, I'm actually back in the school workshop. Okay. Obviously, it's missing you guys for today's lesson. But what we're going to be talking about is we're going to be talking about vacuum forming. Now, more importantly, we're going to be talking about how you create the formers that you need to actually vacuum form in the first place. So vacuum forming is a great tool because what it creates this hollow shell of plastic. So this example you may have seen quite a few times. It's in my room, and this was a rocket lamp. Okay, so it stood up, had electronics inside, lights inside, and it glowed. Okay, so this was created using vacuum forming. Now, what I mean by a shell is exactly this. It's hollow and empty inside. All right, now to make this, what we needed a wooden former. All right, so this former was made and then it was put into the vacuum form machine to create this out of plastic. Now, when you did the polymers rotation, you learned all about plastics, and I actually used the vacuum former. I think I used it with this particular former to shape the plastic. Okay, and I spoke to you about the thermo-softening plastic or thermoforming plastic that we used to create this, and I showed you how it dropped back down again and could be recycled. Now, this is another GCSE project, again a lamp, but as you can see, this whole thing was made using vacuum forming. So actually, vacuum forming was used not only for the main body there, but also for these little wing attachments, okay, that went on here. So a really, really useful tool. So what we're going to do now is we're going to look exactly how those products are made. So I've got a selection of formers here, okay? Now, these were all crafted either using the CNC router in my room or were handmade to become products like these. Now, these two were GCSE projects designed to be lights, okay? This one was actually designed to be a food tray, okay? And this one is a model boat. Now, they all have something, they have different shape, but they all have something in common, okay? What they all have in common, especially these three, is the rounded edges, okay? So if you look at this, you can see that all the edges are rounded. Same on here, all the edges are rounded. Now what that means the plastic is very easy to take off it. What happens is as the plastic is heated up, it's then pulled down as the air is sucked out over the shape. Now what you'll notice on here is you'll notice that this particular former has a series of holes drilled all around it. They actually go to the underneath here as well, these holes here, okay? And then this goes actually up, you hopefully can see through. This goes up to a hole in the end there. What that means is that when the air is being sucked out, okay, the vacuum effect pulls from these particular holes here, so the plastic forms over this detail. So you get this very detailed shape. Now this one does work, but we need to be very, very careful with this. Now we've used rectangular pieces of plywood and MDF in here. Now what we had to make sure it didn't do is it didn't do something called an undercut. The plastic can form over here, but when you have a vertical drop like this, especially if it gets any bigger, it can sometimes mean that the vacuum form won't work. It's always best to add a chamfer. Now, when I say a chamfer, what I mean an angled edge. So if you imagine this here is one of these pieces here, okay? Now, at the moment, the plastic can fall over this, no problem. But so we can remove it easily, what we sometimes do is we sometimes add an angled edge to it like this. That angled edge is called the chamfer, and what it means it makes it a lot easier to remove the former from the plastic once the vacuum forming is done. What we also need to make sure we don't have is any undercuts. Now, what I mean by that is we would never be able to make a shape like this. That's because the plastic can be pulled under there, but then how we remove the mold? The former, will not come out. Because it is hooked underneath here, it won't come out. Now, if you think about when we're talking about plastics, when we're talking about injection molding, we said a water bottle couldn't be made because we weren't able to remove the mold from inside because of the water bottle shape, because it narrowed like this. And we said that the plastic would be like that, but then we wouldn't be able to get this internal piece out because it's much narrower here than it is here. Okay? So we always need to make sure with these formers that we're creating them so that they either have chamfered or perfectly straight edges, so that they're not too high, preferably rounded, and with no undercuts, which is why for this rocket we had to make it in 2 halves. So the student made this half, then made another half and put them together. What we can also add is we can also add little air holes like this to help the vacuum forming machine create the fine detail. Okay? So the vacuum forming process, what I've done is I load my former into it like this. Now you've all seen this one. What I'm actually going to use is I'm actually going to use the boat here and show you how that works. So I place this in my machine here. I get my piece of plastic and I secure that in place. Now what this does when I secure this is this creates a seal. All right? Clamping that down like so has created this seal. No air can get through. That is airtight. So the air that's in there can be sucked out and it won't be replaced with any air. That means that we create that vacuum. You might have heard that used when we're talking about the vacuum of space because there's no air, which means the plastic will then just fall on top of the former. So what I'm doing now is I'm heating the plastic. Okay, this is a heater. And what I'm doing is I'm actually getting down here and looking at the plastic. You might be able to see it warping and moving as it's getting hot. And it's nearly ready to vacuum form. Pull this up, suck out the air, and you see the shape form. Okay? I'm going to pump a little bit of air into it just to try and stop the former from sticking to the piece of wood. But there it is. That is my vacuum formed sheet of plastic. And it should, you can hear the air coming back into it now, it should have formed all the detail that you can see around here. Now this is a slight problem with vacuum forming such a large shape. You notice this fold line and here. This has happened for one of 2 reasons. Either I left the plastic to get too hot, so it expanded too much and then folded back on itself, or the former is too high and again stretched the plastic too much when it was created. This is called webbing on here, and it's something we look to try and avoid, which is why you notice that the other formers that we used were much smaller. So that didn't happen. Now what should happen now is I should easily be able to take this out and then my part will have been created. So nice and easy, what we can do is we can turn this over and you see the former comes out. The shape has been created. I can then cut this out, finish it and shape it, and I've got my plastic piece. What I can then do is I can put this in again and restart the whole process. So I can batch or mass produce this particular shape using that former, and it'll come out exactly the same each time.